Thank you very much, Maria. All right, so hello everyone again. Happy to be here. Um, yeah, we're talking about cloud maturity that we want to achieve with Terraform and Dynamic GitOps, whatever that is. Yeah, so I'll try to guide you around that in the next 45 minutes. It's 30 minutes of me show and telling you something, and then it's 15 minutes of Q&A. Normally, I would say if you have any questions, just unmute yourself and ask at any time. But obviously, this is no workshop. It's a webinar, so I'm a little bit caught off guard. And I hope that Maria will just poke me if somebody asks a question in the chat, so I can still answer in context.
Yes,
Right. So perfect. Let's see. Get this thing started. Okay, I hope you can see my screen now. Let's move the video stream again over to my other screen. So if I'm staring off into space, I'm staring actually right at you. And here we go, right away. So, right. So let's first have a look at why you might be here, right? You might be here not only because you did see a fancy title, but because of Humanitech's offering, and I can't get out of the door. Marketing is going to hate on me if I don't show you at least a slide about our products. So what you see here is the orchestrator, the portal, and Score, which is an open source product, which is a workload specification. And I'll be actually talking about at least two of the three quite a bit, and you will see the other one as well. So it is good to have that as a reference. This is our main offering, and we are also helping our customers with processes and are hopefully getting quite some impact. As Maria said, we have now around 19,000 enterprises in our community on platformengineering.org. And we are happy to get more and more because the more, the merrier, the better the discussions. So if you don't have anything to do around Christmas time, well, just join platformengineering.org. All right, so what else do we do? What we try always to achieve when building internal developer platforms, we're trying to first abstract to get a better experience for the developers, then to standardize to get a better overall posture for the enterprise, which basically also constitutes the part of the maturity because every time you have more mature processes and more standardization, you're obviously gyrating towards maturity. And in the end, because everybody would like to see what you're achieving, you want to visualize the stuff. And this is how we sort our products once again. And marketing, I've done my job. Now I can become a techie again. So what you see tonight is first an explanation about, hey, what is GitOps even? Because there are so many different flavors of GitOps. We need to be on the same page, what GitOps means for me, so that you understand how you can relate to that. I'll talk a little bit about the challenges of static GitOps or normal GitOps. And obviously, I'll present what is, from my perspective, a very good antidote to the challenges that static GitOps poses with dynamic GitOps. Then I'll have a little bit of a demo because I'm a techie after all, right? Can't just show slides. And then we go into Q and hopefully A. Okay, so GitOps. Are we on the same page? Let's find out. I've heard that GitOps is an operational framework that takes the DevOps best practices and applies them to infrastructure automation. This is as general as it gets, obviously, but describes quite well what GitOps is about, but really on the surface level. If you dig a little bit deeper, then according to opengitops.dev, which is the biggest reference I could find, which is vendor neutral, a GitOps system must be, first of all, declarative. Yeah? So you must express your desired state in code. And obviously, you must store it in GitOps or it's not GitOps. You could also do mercurial ops or another flavor, but without version control, it doesn't work. Yeah. Next point, versioned and immutable. Obviously, it has to be immutable because if it isn't, you cannot achieve strict versioning and the capability to roll back to a point in time where things were still good. Yeah. Um, Pulled automatically, which means you need to have a fully automated agent which ingests the changes you propose to your infrastructure and turns that desired state into an actual reality. And because reality might change, that automatic agent should actually also continuously reconcile the actual state to the desired state. If there is any drift, the GitOps, whatever tool should actually be able to mitigate that. And if your system that motivates your changes to the infrastructure into reality is achieving all of those traits, then you are most probably doing GitOps. And this is also the GitOps that I'm talking about tonight. So in contrast, there is something that we like to call a Git-based workflow. The Git-based workflow is literally any workflow where an action on a Git repository triggers some kind of workflow. If you think about software development usually is driven by Git-based workflows. Every time a developer commits something to his code repository and then a CI system builds that into an image of sorts or compiles it or does whatever, this is a Git-based workflow. Yeah? And there are tons of Git-based workflows in software development. And obviously, the mandatory Venn diagram, yeah, Git-based workflows is what the majority is doing, and GitOps is literally what the minority is doing. So now that we're on the same page, what GitOps is, let's have a look at the challenges of static GitOps. So just because you configure stuff as code doesn't mean you already do GitOps. You're most probably doing Git-based workflows or Git-enabled workflows. So developers can stay in code. They have the single source of truth in code, which is great. And it allows you to let third-party tools run policy checks before deployment, which is great as well, because you not only have a system of record for your changes, you also have the ability to apply any kind of testing, standardization, compliancy, security checking before making a change a reality. That is great. But in contrast to that, actual GitOps has something like a GitOps operator if you're relying on Kubernetes, like Argo CD, for example, or Flux. Those are the two that we mainly see in the field, which take your configuration as code and syncs them with a Kubernetes cluster. And then on the cluster, different tools pick up what has been synced and then turn via the desired state checking loop of Kubernetes the instructions of what should happen once again into a reality. That might be, for example, other operators taking over, like a Postgres operator, which takes a description in form of a custom resource, which defines how a Postgres database should be looking like. And then the operator gets triggered into action by the existence of that definition and turns that definition into a Postgres instance, which constitutes the full GitOps cycle in this case. This is, and this is a core trait that we are observing, optimal for deploying air-gapped environments. So every time you rush into an environment which is high security, like real high security, you have air-gapped environments, and GitOps is a perfect way to actually work with these environments, because not only it gives you a clear system of record for any change to the system, so auditing and all of these concerns are cared for. It also gives you, and that is great, a way to invert the communication direction. So you are not pushing changes from the outside into the high security estate, but you're allowing the high security estate to pull changes in from the inside and only ingest if the format looks good and the content looks undangerous. All right. So, but let's talk about some challenges. And right, there are so many, I don't even know where to start. And it is literally a thing, this Venn diagram, so many people are doing Git based workflows and only so many are doing real GitOps, and that's because of the challenges. But let's look at the three main ones. So the obvious ones first. Everything I talked about is static by nature. You need to invest majorly into your toolchain to have any automation beyond pulling the changes in and reconciling them, which your GitOps operator like Argo CD or Flux is able to do for you. Yeah. But if you want to have automation beyond that, then you need to invest even more. Yeah. Not only to have it, but also to keep it alive and to keep it repeatable and consistent what that tool is doing. Let's say, for example, you're having that Postgres operator, which is constructing a Postgres database. You do GitOps for a reason. And one of the main reasons is that the outcome is very deterministic. But as soon as you have these kind of things which dynamically work on what you think is the desired state, the outcome might actually change depending on what this tool is providing. So it is not so clear, once again, from the starting point, from where the developer did his change and provided it as part of the package, which is being held under version control. It is not so clear what the true outcome is. And to keep that process repeatable, make it transparent what changes to this process actually mean for the developer who needs to feed into that process. That is where the effort goes into. And that's also the reason why it's really hard to comprehend. So there are differences between the dry and the wet repository. So the dry repository where things are just a description. The wet repository, if you have that, yeah, where things have been actually reconciled to, but not yet reached the state where all of the machinery has worked on it. So Kubernetes and your GitOps operator have a habit of post-processing things heavily, all of the time, you might say. There's a reason why it's called a desired state checking loop. It comes around every so often, and every time it comes around, there might actually be changes. So, and the third is, and this one is not so obvious possibly, there is no segregation of duties or responsibilities in GitOps. This is not what GitOps is about. GitOps is about starting a process on a code base, defining a way how to get that code base into a system and turn it into actually something that is a reality. That is what GitOps is about. It is not about who is actually working as participant in that process. It is not about who is doing which work. It is not about who is providing which inputs to the process and who is responsible for which outputs of the process. All of those are questions that GitOps really doesn't care about, and basically defers that to either other processes or something like DevOps or whatever. All right. So let's see where we can get from this state if we look a little bit at dynamic GitOps. So if you've remembered the slides from the beginning, one of our products is the orchestrator, which actually lives right here. And let me very quickly explain to you what the orchestrator actually does. It takes the ask from a developer, an abstract ask, for example, that his workload, the system or the service that he's working on needs a Postgres database to not have amnesia, takes that ask, ingests it, or gets it propelled via the CI system to itself, and then has to answer the question on how to actually create that Postgres database. And how it does that is not determined by just anybody who is caring for a different piece of software, but it is determined by the platform engineers. So the ops side of the equation. As you can see, there is a clear separation between those two, the developers and the platform engineers. And the platform engineers actually teach the orchestrator to respond to that abstract ask of the developer in a defined way per environment. And by doing it like this, it not only helps the developer to be able to say, to have these abstract asks, and by that go to a self-service way of living, but also to ignore the environment context. Because if I can ask for a Postgres, I can get it in every environment. I do not need to care if I deploy to development or to production. I will get the right Postgres. Great. And as we are talking about GitOps today, we are obviously not deploying, but we are pushing everything that has been generated by the orchestrator, the whole discrete set of configuration, the deployment, all of the description of how the infrastructure should look like. We are pushing that in form as custom resources into a Git repository. All right, so this is now our not so dry repository anymore. The dry repository lives up front here, where the developer commits to. And then after CI and the orchestrator having worked on that, we actually have a wet repository here, where we can actually see how everything will look like exactly. All right, let's take a very quick look at score, because that's what you're going to see in the demo as well. How does this abstract ask look like? Yeah, if I'm working on a service in Python, I can actually say, hey, I would like to have that Postgres database, possibly also an S3 storage and a DNS name because I hate typing IP addresses. And then I can take the information, which is fed back from the creation of that Postgres database into my connection string here. So I can let the orchestrator not only create the infrastructure, but feed back to the application so the application can actually play with the infrastructure or live on top of it. This is how SCORE works. And it is, as a notation, different to ones you might already know in a way that it is written from developers for developers, with the developer concerns in mind. It is not infrastructure driven. It has a clear focus on how can the developer best specify what his workload needs to have inside of a runtime environment so it can actually work in the way it was intended. Nothing less, but also nothing more. So possibly a different level of abstraction than what you're used to. Okay. So, and then I need to somehow get the curve to Terraform, right? And then the platform engineers teach the orchestrator on how to respond to that ask. And as you can see over here, that looks eerily like HCL, and over here as well. So as a platform engineer, I can now teach the orchestrator how to respond to these abstract asks using Terraform, because we have a Terraform provider. So you can define your resource definitions. In this case, for Postgres, yeah, you can define that in HCL. And I have no idea why it says Cloud SQL static here. It should actually be Terraform. So I need to change the screenshot. Oh, good that I see it now. And here are the criteria which specify under which conditions this definition should be applied. And you could, for example, say, hey, every time something is planned to go onto a development system, or hey, every time something is going planned to go onto a production system, or in this case, hey, if an application which is called test app is coming around, we're going to use this definition here, which links to the actual Terraform code, which later on creates the whole environment. Yeah, and by that, you're going full circle on Terraform. and you're doing what Terraform is usually not exactly good at. You're providing resources from Terraform to developers in a self-service fashion without developers needing to actually configure resources or learn HCL or run Terraform in any way. All right. If you've never seen this, this is actually what I will use to demo later on. This is one of our reference architectures for internal developer platforms. And I'm just putting this up here so you have an idea what I actually stood up using Terraform for you tonight. And if you have all that, this is what you can really easy do. You can have a Git enabled workflow. Yeah. So the orchestrator can very easily take this score file, which describes what should be built out from CI, accordingly also with the description which image should be deployed. Yeah. On the platform level, ingest a whole lot of configuration as well, generate the result and output code. So put that into wherever. And wherever in this case could be directly a Kubernetes cluster. Yeah. It would still be a Git enabled workflow because it is based on the trigger that the developer commits something into a version control. The platform engineer commits something into a version control. And from this event on, we go and walk through that flow. Yeah. But it is no GitOps because we do not have a system which is pulling, and we do not have a system which is continuously reconciling, because the rhythm of business for the orchestrator is the deployment. Every time you push the button, it goes there. All right. So let's have a look at the mode of operation with GitOps. How does that look like? Platform orchestrator puts everything into a Git repo. From there, the GitOps operator, which lives over here in your Kubernetes cluster, let's say Argo CD, pulls all of that in. Yeah, so a lot of custom resources are now in the cluster. The humanitech operator takes note of that and is summoned into Acton. It calls out to something we call drivers, which actually interface with the infrastructure and motivate them into life. Obviously, from the title of the webinar, you know that the Terraform driver is being called to create the infrastructure, right? And in this case, we're provisioning the infrastructure right back into the cloud estate that might or might not be inside of this dotted line, which is the border of the Kubernetes cluster, right? So, and then in the end, we put out some manifests which describe the deployment. Kubernetes takes note of that, loads the image, gets some pods spinning, creates instances, and then we have a running system. So what's the difference between GitOps with and without humanitech, or in a static way or in a dynamic way? In static, you can only sync static files until you invest a lot of work or you invest your developer's cognitive load into learning things like customize, for example. So you can start on templates, then you need to, during the process of creating something inside of your GitOps workflow, you need to invest into turning these static definitions into at least some invariants. So all downsides of static apply, right? Everything I've talked about, which is problematic, developers having huge cognitive load, needing to provide configuration for every environment, needing to learn things which are inherently looking dangerous, like Kubernetes, or even worse, whole different level of scary, templated Kubernetes. And with dynamic GitOps, all of that goes away because everything of that this complexity is normally onboarding to your developers is being cared for by the orchestrator. They just have that very simple syntax. They can ask for the infrastructure. The orchestrator creates a description, creates schematics on how to build that. And because of that, you only need one description for all of the environments. And every time you deploy, every time you go through that process, everything is dynamically generated, which also gives the other side of the equation, the platform engineers, the opportunity to continuously evolve how the infrastructure is being created, yeah, and provide those updated definitions how the infrastructure should be looking like as well to the process. And every time something is deployed, all of these changes are taken into account and then provided as entry point for the GitOps workflow to execute a whole package of changes, which then is in a real GitOps way, not only brought into life, but also continuously reconciled and being kept, then the system is being kept in the desired state. All right. So I've been talking and talking and talking. Finally, let's show you how this looks like. Okay, so let's see. I need a terminal, obviously. I'm a techie here, so can't just run in the browser, right? So projects, go Argo or GitOps with Argo CD. I prepared Argo for you tonight. And I'm setting here a little bit of an environment so I can actually show you how this comes together. And what I'm also going to do now is I'm going to take a look at the orchestrator, which is sitting at humanitech.io. And I'm living inside of my Argo demo account right now, or my Argo demo tenant. And currently I have an application, yeah, which is having two environments, one called development, one is called GitOps, which looks interesting, right? I have resource definitions over here. I have two Kubernetes cluster. One, actually, they are the same Kubernetes cluster, and that's the fun with resource definitions. I can have many which target the same thing in the end, and one of them is targeting directly here, so deploying directly to the cluster, and one of them is actually providing a Git target. And if I look into here, into the configuration, I can see to edit, so I can see better. There is github.com hcc demo argo demo.git. And if I take that here, copy that, cancel, so I don't ruin the evening for us all, and go over here, I can see that my whale application is ending up as a repository here, or in the repository here. And if I go in here, I can see that here are resources and a workload in YAML format. So these are the custom resources which are generated by the process and describe how this will look in the end. So now the question is, do I have that on top of my runtime environment, on top of my cluster? Let's have a look. If I do a kube control get namespaces, I can see that there is a whale namespace. Yes, it is active. So let's get all from the namespace whale. And you can see there's nothing in there. I only have the namespace. And I also have Argo CD prepared. So if you think about this reference architecture, that is completely stood up. And then I have put Argo CD in there as well. As you can see here, there's nothing in here. So the only thing I've prepared, so I don't have to click through that, is I've taken a score file and projected it at the orchestrator. So you already have some, or we already have something that we can play with. So I'm going to say, okay, I have a new application. The application name is going to be whale. It's living inside of the default project. I'm going to manually sync because if I put that to automatic, changes will be so fast, you will not see the fun. Okay, so we're going to auto create namespaces if needed. The repository URL is already configured because that's a private repository. I need to authenticate. If you ever do that in Argo CD yourself, always go to settings and set up the connection to your Git provider first. If no, you don't do that, you can't just pick it here and then you don't have any way to inject credentials. So you can only work with public stuff. And then you type all of the stuff in, and then you hate yourself because you have forgotten it. We've seen in the repository that we need to use the path whale, and we can take our main cluster. Namespace is also whale. Going to recurse directories. Everything looks good. So let's push the create button, which now creates the application in Argo CD. And if I go in here, I can see, okay, there is whale, and it sees the 3 resources I have in the Git repository. What I now can do is I can push the sync button because this is not auto syncing, or you wouldn't be seeing what's happening. So I've basically taken the liberty of preparing the deployment up to the point where the GitOps operator takes over for the first one. So we're going to synchronize now. And what should happen is, as you can see, that this unfurls now into what is actually running on top of the cluster. So out of the 3 things, a lot more comes out. We have a deployment here. I don't know if you can see that very well. Let's just hope for the best. Okay, so deployment comes out of this. Yeah. And then we have a replica set. And then over here, where I can't scroll to over here, we have the pod, which is running the application. And then we have a whole lot of supporting stuff. Yeah, we have a config map up here. We have projected secrets. We have a service, and we actually have an ingress fronting all of that, so we can access that. And all of that is being created from those resources deployed here. Okay, that's great, right? But let's go back to our example. We definitely need some Terraform in here, and we want to have a Postgres database. So what I've also done is I have already downloaded a resource pack in cluster. This is something that we provide as part of our reference architectures. So when you take a reference architecture, you can actually use these in-cluster resources. So you could literally deploy that on your own notebook, yeah, and make it really easy to work with stuff, because then you don't need to have cloud provider services, and you don't need to invest a lot of time to get to a state where you can actually start tinkering around. Right? Because we have these packs which provide you with ready-made resource definitions that in this case give you just an in-cluster Postgres image. And in this case, it's all Terraform once again. I can do a tf plan here. You can see it needs to add 2 resources, and it will add them to the orchestrator. So let's do a Terraform apply. The auto approve. We've seen the plan is good. So let's apply that to the orchestrator. And if I walk over here, I can now see inside of the resource management, I have applied this Postgres resource definition. And now if I go in here, the only thing I need to do, because I haven't done that, I haven't adopted the Terraform in any way. It is literally how it comes out of the Git repo. Yeah, I need to add new criteria that everything that goes to our GitOps environments should actually use those resources here. Yeah, great. So now we have the right matching criteria, and now we can actually do changes to our application. So I can do that in 2 ways. I can either do it like a developer, or I can do it like somebody who is a little bit more in a clicky flow. And I'm going to be in the clicky flow for the moment. I could also just change the score file and redeploy that one. I'm going to do it like this now. Okay, if I look here at my whale-say service, I can see that there is no ingress, no service account, not so much, but there is a container. And it is actually having a few variables being set, and it is running whale-say-d from Docker Hub. And what I do want now is I want to have an additional resource. So I'm going to push the Make Changes button and add a new resource dependency on a Postgres database. Obviously call it Posty. And that's everything I need to do. I could also, just to have that example for you, go score.yaml. Yeah, so this is the or wait a moment. Of course, don't do that in the Terraform directory. If I do go in here, I could actually also go in here and say resources. Let's say hosty type Postgres. Sure. No, Postgres. And now I could take this file, take it as input also, and trigger the process from there. But for you to follow along, it's more easy to see that one here. So I'm going to review and deploy this. What I immediately see are the material changes that I've done. I've added a Postgres database. Great. With DB, let's deploy this. And what's happening here now is that this is going directly into a stopped state, and it is that quick. And the reason behind that is, once again, if I take a look at this Git repo, I can now see, if I reload this, I don't have 3, I have 4 resources in here. And it was just now committed. And the reason is that one of those is now a description on how to build out that Postgres database. Let's see if I can find it. Obviously, that was the wrong one. Yeah, here we go. Dev in cluster Postgres. This is a description on how to actually build out this Postgres database. And you can see that there's a lot of stuff happening here. But in the end, where is it? Postgres version 15, that image is being run inside of the cluster. So my application then has a database. And let's see how that looks on the GitOps side, right? Let's zoom out a little bit because then it looks, oops, that was not what I wanted to have. I wanted to zoom out a little bit so you can see all of those resources, because I think that's like literally the most interesting moment when you actually start deploying something and then you see live the changes which are happening. Right, so I'm going to refresh this and then I can see, okay, it should be out of sync. Yeah, and I can already see, so here's a resource which has a little yellow ghost that's not present yet. And there are changes to all of the other ones. So let's sync this and see what happens live. There you can see, okay, first of all, it went to a degraded state. Yeah, we had the Postgres definition, but it wasn't yet an instance. And then it unfurled. And now I can see I have my Postgres pod over here. And I have a whole lot of stuff around that. Yeah, which is now part of my application graph. So this describes also very clearly how my architecture looks like as an added bonus, right? And that is literally how you can achieve very high maturity level using Terraform and GitOps, as I would say, in easy mode, because you have the orchestrator up front, which is preparing all of the inputs for your GitOps process, and which makes the configuration that you need to put into your GitOps tool and that you need to actually provide to make all of the rest happen very easy. And while doing so, you also get for free the whole dynamic GitOps. So 95% less configuration files than if you would be using other notations, which include all of the environment-specific configs, and also the self-service for the developers and the reduced cognitive load. The great visualization and the tooling that everybody is also wanting to have, Argo CD or Flux, you get that obviously as well. You could say you're getting the cake and you're also allowed to eat it. All right. So I hopefully have demonstrated in a very easy scenario how that comes together. Right? And before I jump to the next slide, which says Q&A is now open for everybody. Let me quickly summarize on how you could get there very easily and quickly. You could just go to humanitech.com, look for the keyword reference architecture, jump from there to the Git repository where they are living. Get yourself a reference architecture, get yourself one of those in-cluster resource packs, and then you only need one more ingredient, and that one you can get on developer.humanitech.com, which is where all of our developer documentation is living, which also includes a tutorial, a step-by-step tutorial on how to turn the orchestrator into GitOps mode, how to set up Argo CD, how to set up basically everything you've seen, how to set up our own operator, how to bring it all together. Yeah, and I have done this actually to upgrade the environment to the newest version today. And by now, I'm possibly quicker than you will be on your first try, but I can confidently say that you will be able to play around with something if you follow the tutorials in about 2 hours. You will have the whole thing available at your fingertips. All right. So having said that, let's push the button and go into questions and hopefully answers.
It's your new category, Clemens, no? Questions and hopefully answers.
Yes, that's how I roll.
First, yes. Well, thank you so much for the session. And just before we jump into questions, I saw there were some also interactions in the group. The recording will recording and slides will send over to everyone tomorrow who registered for this session, as well as I included the link to our YouTube stream. You can just save that as well if you want and send it to your colleagues or check it out if you want later on. And yeah, sorry, I didn't stop you during the session, but there are quite a few questions in the Q&A section. So I guess there was this first question and everyone kind of like jumped in into answering, just like from your side to confirm. Can you go deeper into what wet and dry repositories are? And there are like explanations: dry, do not repeat yourself; wet, write everything twice. So
right. Do not repeat yourself is a great long form of dry, but not what is meant in this case. In this case, dry is like pre-hydrated. So if you look at deployment manifests, they would be pre the state of being hydrated. So just the manifests, and then you possibly have a wet repository where you already worked on those manifests. Yeah. So let's say you have a deployment description like a Helm file, a Helm chart, pardon me, right? And that Helm chart describes how your application is being deployed. It doesn't describe how your infrastructure is being deployed. So you need to fuse those two together somehow. How do you do that? You actually create the infrastructure, and from the creation of the infrastructure, you feed back the relevant parameters into the configuration, into the values files that then get put back together with your Helm chart for the deployment. And this process is going from the dry version of all of that to the wet version. Yeah, so you are hydrating the manifest with the relevant configuration before you do the actual deployment. And if you are in a more sophisticated GitOps shop, you will have wet and dry, and even after that, possibly also another form of repository which covers the end state, because what is the desired state must not be the end state. And as I said, sometimes catching or persisting this end state is also vitally important for things like auditability. Yeah. All right. I hope that was good enough as an explanation. If not, and you feel like wet and dry repos still feel fuzzy, I would say go to open GitOps.dev and have a look. If I remember correctly, they had a very good explanation. All right. So let's have a look.
Next question. Are the operators for platform services, for example, Google Cloud, run Azure Container Apps, or is it Kubernetes prerequisites?
Mm-hmm. Yeah, so I must say that the sweet spot of our orchestrator is actually deploying to Kubernetes, right? That's why we also team up with our own operator to make these GitOps flows happen. There are other means on how to actually deploy things like Cloud Run functions or container apps. And yes, if you want to do that in a GitOps way, you're either be using plugins for the GitOps operator of your choice, which make that possible, or you're using operators, which then work on the custom resources to provision the things that you want to have in the end. The sweet spot for our orchestrator, though, is Kubernetes for sure. So that is a prerequisite, yes. And that's also one of the reasons why we say in the end, you need to build your IDP. You can't just buy one because there is no solution out there today that I know of which covers all of the runtime estates out there, and in especially the way that you want to have them. So you possibly need, if you have a need to provision all of these runtime estates, you possibly need to take a few technologies and fuse them together into your platform. Right, so next one.
Yes, next one. It also, I feel like there were some discussions in the group around that one, but if you just want to confirm, Clemens, and how do approvals work in the GitOps model? Do you get a visual plan that you can use for the organizations that need more formal change management, for example, CI, but manually delivery?
All right, cool. So, yes, disabling autosync is definitely not GitOps, and you're completely right there, Christian. This was for the webinar, so you can actually see those changes, because if I don't do this in manual sync, the moment I do the change in the orchestrator already before I am switching over to the browser, the changes will have been done. Yeah, and you cannot see the unfurling of the objects and how the graph is being changed inside of Argo CD. So just to have that flashy piece of show, I need to disable the autosync. It's just too fast. I'm sorry. Right? Approvals happen via PR to trunk. Yes and no. Why yes and no? Because there are different groups providing inputs to your GitOps process. And depending on how these things need to come together, you cannot always just curl everything into one pull request. Sometimes you need to align things, and you need to work on a different repository, which is probably not even yet the real entry point to your GitOps process where you pull in. Yeah? And that's the reason why we think that as soon as you generate the desired end state, that's where you need to have the approval. Yeah? And yes, it would be nice to do that looking at the sync studies in Arco, but that would be too late because then it's a reality already. So you need to have that before. And what we have in stock is we have a capability inside of the orchestrator, which we call pipelines. And pipelines are built to actually handle environment progression. So if something should be going to an environment, it will go through a pipeline to that environment. And the pipeline can, in the same way that you work with GitHub Actions, can be built out using steps. And steps might be run an automated test set and only progress if the answer is tests are green. Have a manual approval. So somebody with the rights and roles needs to sign on and actually prove that the deployment should continue. Call out to an arbitrary piece of software like a policy agent, like OPA, Open Policy Agent, and do a crazy policy check. Yeah. For example, if somebody has actually done his mandatory, what is really crazy, has done his mandatory ethics AI training before he's allowed to actually deploy a large language model to a cluster. Yeah. So stuff like this, completely possible. Those can all be gates inside of your pipelines, which need to be check marked before the deployment is able to progress. And as part of that, you can actually have a look at the application graph on our side of the pond, not in Argo, which is the live view, so to speak, of the runtime estate, but on our side, which gives you almost the same visibility, just in a more abstracted way. Okay.
Nice.
Yeah, and GitOps is a crawl, walk, run type of adoption. I wholeheartedly agree.
Good. Next question. What is the tie between the definition and the module? Can you bring your own resource modules?
Yes, absolutely. So what you've seen me do is you've seen me use a custom definition on how infrastructure is being built. Yeah. And I've used a definition, which is the thing that ties together which basically tells the orchestrator, hey, in this case, use this way to create the infrastructure. And you are absolutely able to bring your own. You can bring your own Terraform modules. You can bring your own modules in other IAC languages. You can use all of our open source drivers, which connect directly to cloud infrastructure and make it very easy and in a very abstracted way to actually reach outcomes. You can use all of that to describe how infrastructure should be built out. Why do we provide so many on-ramps? Well, because in the end, every customer for us is a brownfield situation, right? And that means we need to be able to let you keep your investments. Yeah? So you've probably already have Terraform code written, which creates your infrastructure, and you should be able to reuse that. Just let somebody else take over the life cycle, the execution. Yeah? And this is basically the pattern that we're following. With the orchestrator, we are providing you a way to define in a very easy form, once again, what module should be called in which way, under which circumstances. By that, enable you to reuse your existing IAC estate, but provide it as self-service to developers and make it really easy to unwrap this whole GitOps process around it. Right.
Next question. Does Core support platform service, for example, Kong or Azure API management for defining API policies or Internet API gateway proxies? Okay. So Stu says you probably answered this one with the
Yeah,
last.
I probably did. So just let me add one more shade of color to it. Yes and no. Yes, because literally you can, as a developer, you can request everything using Score. And then the question is just, does the orchestrator on the other side or whatever platform is running on the other side, because Score is an open source notation. It is not bound to Humanitech. It is a great notation to put in front of your platform, whatever that platform is, right? So if you've reached that state, then in the way how you're working together with Humanitech, you would define how these platform services then get created and configured on the side where you basically create them, literally in Terraform, for example, if you want to do something very specific. And then bind that once again with a resource definition so that the request of the developer is fulfilled. So you would not put all of the complexity into Score, but rather once again try to have a segregation of concerns. Let the developers serve the business need by providing business logic, develop things, and let the other people which are living more inside of the domain of the infrastructure or providing these kind of services inside of your company, enable them to provide those services in a nicer way to the developers and cope for the complexity that is inherently ingrained into these into these solutions. Okay. What
Funny
that
question.
one is that is the one thing I can't do. I'm just reading the next one. So what is the pricing licensing model for Humanitech? So this is the one thing I can't do because I'm the techie, right? I'm only very loosely coupled to sales. And so I can stay away from pricing. All right, so let's see what I can do for you. So no, it is not based on resource numbers. It is based on number of developers, so to speak. Yes, so on users actually using the system to create something. Yeah, so developers and operators or DevOps or however you call yourselves, platform engineers, yeah, they would require seats, yeah, and everything else is royalty free. Why? Because if we would license in any other way, we would emphasize people to take bad decisions. For example, if you have a system which is making you pay on the amount of services that you're deploying, you're most probably going to try to look every time and say, do I really need another service? Or can I just build one of my service into a bigger monolith, which is a really bad architectural decision, right? So we're trying to make people get all of the value, let ourselves live from what we are doing, yeah, and in the end, give you a way to stay on a good decision course. That's why we have this licensing model. And I can also say that there's a new pricing coming, but this is literally where my understanding is vague, because I'm the techie, right? I have a feeling that there could be a pricing page on humanitech.com where you could get more info. Right. In this model, where can one put in automated testing for applications? Great question, Somil. I think I answered that one. As part of the environment progression, using pipelines, that's where you would anchor automated testing. You could, for example, after a deployment to a system, let an automated test set run if it's the development system, and then say, okay, developer, you did your job or you didn't do your job well. And depending on that, do certain things like roll back to a previous state or send messages out or whatever. Or you could make such a test set mandatory as an automated measure between QA or pre-prod and prod. Yeah, like if you have a certain pattern which arrives, which is your release candidate, and it arrives and is conforming to an approval and an automated test set delivering green results, then it can automatically be promoted to production. Something like this.
Cool. And the last question, does this pattern help with cherry picking hell that you can get into with GitOps in terms of making the selecting of what commits to deploy easier?
Absolutely, right? Because this lives before the GitOps operator takes over. Yeah, and it is a way to actually do this. Yeah, a better way to do this on how to select what is going to be part of your next release. Yeah. And by providing you with these facilities and having a clear idea on how to make that happen, on how to create the end input for your GitOps progression, that is helping with exactly this.
Nice. So I feel like we're a little bit over, Clemens. We're already in 1 hour, but while I'm wrapping it up, you still have time to type in the last question. But as I mentioned, we're going to send over the webinar replay and slides tomorrow to everyone who registered. Also, there is the YouTube stream you can check out or forward to your colleagues. As well as platform engineering Slack. make sure that you join the Slack and don't miss out on any platform stories, user stories. There are a lot of interesting conversations happening over there. And yeah, we're meeting with the platform engineering community every week. Check out our events calendar, sessions calendar. It's usually something around, all of the hot topics within the platform, within DevOps, within all of the cloud native technologies. And you can also submit topic as well if you're interested and become a speaker yourself. Lastly, I didn't see any other questions, but thank you so much, Clemens, for spending this evening with us. And well, I'm sure we'll see more of talks from you. And yeah, reach out to Clemens if you have any other questions within Platform Engineering Slack, or also Clemens likes to share his special handle in Slack. Is it Jay?
Right. It is Jay. So at Jay will directly summon me. Yeah. If you do not do that, I might still answer, but it might take some time because, as you can imagine, there's quite a buzz on platformengineering.org with the amount of people which are living there. And I also have to live on a few other Slack spaces. So if you really want to get into my inbox, please tag me at Jay and I will be there for you. Yeah.
Yes. Hope everyone has an amazing rest of the day, rest of the week. Hope you stay safe, especially within this snowy winter and interesting world we are living in. And have a good night, everyone. Bye, guys. Thank you, Clemens.
It's summer here. I want to trade. Thank you, everyone.
Well,
I had
good for
fun.
you,
I
Stu.
hope
Good
you
for you. Good
have
for
a
you.
great evening as well. And have a great